In this video, I'm going to go through the trickiest part of simplifying algebraic fraction, which is adding and subtracting them. And then I'm going to go through some harder examples that we can try and do. So that would basically cover everything related to algebraic fractions. So remember, for fractions in general, as I mentioned before, multiplying and dividing fractions is easier than adding and subtracting fractions. And just how when you want to add or subtract fractions, you want to make the denominator the same. It's the same exact idea for algebraic fractions, except that making the denominator the same is slightly different, where we have to think of the denominator as algebraic expressions. So for example, let's say I'll go through a few simple examples just to cover how we want to make the denominator the same. So I have 1 over x plus 1 over 3x. So right now I can't simplify this fraction because the denominators are not the same. If it was multiply, I'll just multiply across, but right now I can't do that. So what I need to make sure is the denominator is the same, and I can't change this 3x to x. I'll have to divide by 3, and we don't tend to divide fractions. If we want to change them to another form, we tend to multiply. But I can multiply this whole fraction by 3, and remember, you need to multiply numerator and denominator by 3. So the reason we do numerator and denominator is because it doesn't change the value of the fraction. If you just multiply the denominator, it's going to change the value of the fraction, and your equal will no longer be equal. So right now I'm going to get 3x plus x plus 1 over 3x. I have the same denominator, so I can bring the fractions together, and then it's just 3 plus 1. Then you just add or subtract the numerator, whatever it is. So this will simplify to 4 over 3x, and I can't simplify it any further. So this is as simple as it gets. So this is one of these simple examples. If we change it a bit and we make it an expression, so if I have x plus 1, and I'm adding a 1 over x minus 2. So remember, and this is a trick I mentioned before, is that the denominator is enclosed and numerator are enclosed inside brackets here. So I can't change the x plus 1 to an x minus 2, and I can't change the x minus 2 to an x plus 1, just as we did here. We can't do that because it's a whole expression that I have to change. Some of you might be tempted and say, well, I'm going to add 3 here. Well, we don't change numerators and denominators by adding, subtracting, or dividing. We can only change the look of the numerator and denominator by dividing or multiplying. By multiplying only. So only multiplication. So because we can't change either to the other, one to the other, I'm just going to multiply this whole thing by x minus 2, and then this whole thing by x plus 1. It's the same as if you had a fraction, for example, 1 over 3 plus 1 over 5. I can't change the 3 to a 5, nor a 5 to a 3. So what I'm going to do is I'm going to multiply this by 5, and I'm going to multiply this by 3. It's the same idea here. I'm going to multiply this whole thing by x minus 2. And then this whole thing by x plus 1. So if you're comfortable with adding and subtracting normal fractions, adding and subtracting algebraic fractions shouldn't be as scary. Students just don't like them because it tends to involve algebra. But try to bring in some numbers maybe just to make yourself more comfortable, and then bring in the algebra in there. So x minus 1 times 1, this will just give me an x minus 2. So I have x minus 2 here over, now this is going to be the x plus 1 multiplied by the x minus 2. Don't expand them out just yet. And then this is going to be x plus 1 over, again, the x minus 2, x plus 1. Now in multiplication, it doesn't matter. X plus 1, x minus 2, x minus 2, x plus 1, these are exactly the same. So I can just bring them into the same. And if you're not convinced, well, just remember these two are being multiplied. These two brackets are being multiplied, and 3 times 2 is the same as 2 times 3. This is the property of multiplication. They're commutative. So these two will be exactly the same. Now, x minus 2 plus x plus 1. Remember, there's a bracket here, just in case you're confused what to do with this addition. So you have an x minus 2 plus an x plus 1. If this was a minus, then the minus has to spread out to each of these values. But in this case, it's not. So I don't really need the brackets, but I can go through it. You guys can, if you're comfortable with the algebra, you can immediately just simplify from that previous step. But I'm going through more detail just for the people that need it. So this is just going to be plus x plus 1. Again, if it was minus, it's going to be a minus x minus 1. So just be aware. That's why I put the brackets in there, just to make sure we do it. Now, I simplify, I collect the terms together, x plus x, that's 2x, minus 2 plus 1 will give me a minus 1, and that's just x plus 1, x minus 2. Remember that you can't cancel things out because this whole thing is 2x minus 1 inside a bracket. If I wanted to cancel this, then I'd better have a 2x minus 1 as well in the denominator. Some of you might be tempted to cancel things out here, which would basically undo what you did, and it doesn't make sense because remember, this is a bracket added to another bracket. They are not being multiplied. If they were being multiplied, then you can cancel them out. And these tips were mentioned in the previous videos. Now, what if we had something even different, and I had 1 over x plus 1 over x plus 1. This time I can multiply this instead of by a number and instead of multiply both of them by an expression. I can actually just change this to make it similar to that by multiplying it by an expression. So I can multiply it by the x plus 1 and x plus 1 here. So this is going to give me an x plus 1 in the numerator. This is going to be x plus 1. This stays the same. I have the same denominator, so bring them together. X plus 1 plus 1. I could put brackets in there if I want to, but it's not an expression. So x plus 1 plus 1, that's x plus 2 over x plus 1. Now, if this was an x plus 2, then I can cancel these two out. But it's not, so it's an x plus 1, and that's as simple as it gets. I'm going to bring in just an example where I do want you to pause and try it out. It's going to be a bit longer to deal with. So if I have 3x over x plus 3 plus x minus 3, and I'll put the brackets in there, I have x minus 3 over x minus 2. And I want you to write this as a single fraction. And you can pause the video and try it out. So, as the previous example, I need to change the denominators to be the same, and I can't multiply them by an expression nor multiply by a single fraction by a single expression, nor can I multiply by a constant. So I have to multiply them by the other denominator. So the top is going to be multiplied by x minus 2. Sorry, the first one is going to be multiplied by x minus 2. And the second one is going to be multiplied by the x plus 3. So just to be clear, these are the things that were multiplied. And we expand out the brackets. I can actually bring them into a single fraction. And I'll just multiply this out. So I'm going to get 3x squared minus 6. And I'm going to multiply this whole thing out, but I'm going to keep the plus and I'm going to keep the brackets. So I'm just going to expand this now. The reason I always keep this plus is because sometimes when it's a minus, it gets a bit confusing. So I want you to use the same habit. So if it's a minus, just keep the minus there, open a bracket that will put whatever you've simplified here. This is going to be an x squared minus 9. This is the difference of two squares. So, it's too far. So expanding out to the addition. If it was a subtraction, just be careful. But in this case, I'm just gonna expand the addition. Okay, so I get plus x squared minus 9 over x plus 3, x minus 2. Don't expand the denominators just yet, and try to avoid expanding them just until you get comfortable with until you might think that you might need to expand them. Just need to double check. Yeah, I made a mistake here. This is 6x and not just 6. So try to avoid these tiny algebraic errors. Collecting the like terms, I have 3x squared plus x squared, so that's 4x squared, and then the minus 6x stays the same, and then I have the minus 9, x plus 3, x minus 2. Now, if this is the case, it's very tempting to see, well, maybe if you're left with this, maybe this does simplify, and the numerator does factorize to give me a nice factorization of the quadratic, and maybe from there you might get a something that would cancel out with the denominator, and you can try and factor them out and see what you get. But depending on the marks for the question, if it was a lot of marks, then yes, they would expect you to have factorized it. You can try, but you will soon realize that this does not have a nice factorization, so it doesn't actually factorize. Sometimes it does, and it cancels out nicely with the denominators, but in this example it doesn't, so this is where we're going to stop. So this is where I'm going to stop the video at the moment. There might be other videos where I'm going to follow up through some additional examples they could do, and maybe harder examples that you could try, and I'm going to go through.